like it. Let me try to stop
Okay,
sharing my video. All right.
we're
Let me know
good.
when you're ready to go.
Yeah, we're ready to go. It's all, yeah, go for it.
All right. Yes, you can start recording whenever. Okay. Cool. All right. So this is a demo here about ghidra, and really quickly, I'm going to talk about what ghidra is, and I'm going to talk about where I'm getting this from, and just kind of go into that. All right. So for people who don't know, there is for a lot of CTFs, there are a lot of reverse engineering challenges. And I used to have a lot of trouble with them when I was playing with them, and I'm still learning about it. But one day I finally learned about ghidra, which is this really cool software reverse engineering tool that was released by the NSA, and it's awesome. It's Java based. You can just download it and just start running it, right? So what this allows us to do is disassemble binaries into the assembly code that they're in, and then get some idea of what the original source code that they were written in is. And we'll talk a little about that as we go through the project. So the blog that I got this from was the author was Stephen Patterson. This is the blog that he runs, and this is about a crackme challenge that I got the source code from this GitHub that was in this article. And we currently have that crackme running on my Windows VM here. So like Candy was talking about earlier, this is just a Windows developer VM that I downloaded straight off the Microsoft site, and it's just temporary license. So we've opened PowerShell here in this directory. We do that just by doing a file and then open PowerShell, and then here we are. So I'm just going to run the crackme really quick, if it runs. Okay, there it goes. So it's asking for a password. So let's just type in password. And so that didn't work. That password was invalid. All right. So we need to figure out what that password is, and we need to figure out what's going on in that binary. So let's kind of flip to our ghidra tool. So I have ghidra here. It's installed in my op directory. That's a pretty typical place that you want to put any third-party software on Linux. So when you start ghidra, you need to create a project. So I've already done that. You just go File, New Project, and then you just name it and save it. So now we need to import the files. So we're going to batch import the files for that have those binaries in them into ghidra, and ghidra is going to take care of some of the analyzing for us so that we can start working on it. So we'll go here to the radar workshop 22 master, LOE crackme, and bin 32. So I'll click, and then I'll hit the shift key, and then I'll select all the files, and I'm going to go ahead and hit OK. Really quick, portable executable format, PE, and then what type it is. So x86 and the language and the default and its Windows. Portable execution format. This is a very popular format used by Windows programs for creating things like .exe, DLL, and sys files. It contains all of the x86 instructions that you will need to run the executable on a Windows computer. And that sort of stuff sets up in a file format that sets up and informs assembly what you're going to start creating for your stack frames inside of the system. So let's go ahead and hit OK. So ghidra is going to start importing our files for us. And a lot of information is going to run here. And it's just going to take a second while it brings everything in. So we hit OK. Cool. So now all of our code is imported. And then we're just going to go ahead and hit the dragon to open the crackme. Awesome. So that's going to take a second for it to load. Awesome. And I did not click on the right one. Always have to make sure you click on the right thing. No big deal. So try it again. Cool. So Ghidira's code browser is going to open First, it's going to say, has not been analyzed. Do you want to do that? And I'm going to say yes. So we get a lot of different options in here. If we're working with the .exes, sometimes this, this propagate external parameters option is not selected. So we can go ahead and just hit select all. And ghidra is going to go ahead and start its analysis. So the whole point here is we need to find the password, right? So we have to disassemble the code in order to do that. And we're going to let ghidra kind of do its thing here. I like to use ghidra on a Linux system just because I don't have to set up any of the Java paths. If you do this on Windows, you will. Cool. So now that that's disassembled, all right, so here's our main window. And here is our program trees. And here's our symbol trees, and here's our data types. So program trees contain everything from our headers. So this is our DOS header to our text. And that's the actual program code. And our data and our data, BSS and iData. These other sections here are going to contain like imported libraries and different strings and like the memory translations that are going to be needed in order to make the exe go. So let's just start here. So with the program trees, we can right click on this folder and we can start sorting these. So we're going to modularize by the dominance. So ghidra is going to do its thing, and then we get a dominance folder here. And we could also sort by like complexity and depth and other things like that. And then we could do like isolated entries and other things like that. All right, cool. So kind of looking at some of this here. So ghidra will decompile what we're looking for as we start looking through the code, and it will spit that information out over here. So let's go ahead and just kind of start here, right? So the next thing that we need to look at is our program trees and in the symbol trees. So let's go ahead and expand our import. And we've got the Kernel Dll. So this is like a library that Windows will bring in that allows you access to a lot of System32 files. So we'll kind of expand that. And now we'll go into here, which is like the main DLL. And what we're looking for is we're trying to figure out what does this program actually do, right? So now we're going to go back to our main program tree, and we're going to start trying to figure out where that might be. So what we're really looking for is we're trying to find our main, right? That most programs are going to have a main. And so we want to figure out where that might be. So we're going to do another sort, and hopefully we find something in here that's going to help us with that. So we're not finding anything. All right, and that's kind of the process here, right? Like it takes a little while for you to start sorting through all your different code and find your different things, and then find, you know, the pieces of information that you're looking for. All right, cool. So we did find our main. Awesome. So we'll go here. And as we can see, like as we start moving through the different code, ghidra is going to start decompiling it. And so a lot of these things were not written by the original author. Like we can definitely tell when we see things like this Ming GW, that's a C compiler, C++ compiler, I think made by the LLVM team. So as we keep dissecting through ghidra, it's going to keep finding these different things for us, right? So one of the things that we will want to do is once we identify what our main is, we want to go ahead and have it show references to. So this is going to show the different references in terms of the different addresses, right, that we can see in here, right? So we've got our addresses and then some of the assembly instructions and then what it's doing. And then, so this location is where the first entry into the program for the main is. And here it is, right? So now we found where that code is that contains all of this, right? And so main has a call that makes the call, and then there's the address itself. Well, that's great, but as we're going through this, we kind of want to find a little bit more information, right? So, and one of the things that we're going to want to make sure that we pay attention to is ghidra also allows you to like move everything around, and it has a lot of different tools. It has a lot of different functionality. You can extend it. I've only begun to just start playing with ghidra, but there's a lot that can be done with it. So another type that we need to look in here is our data type manager, right? So there's the built-in types that it brings in, and those can be informed by the headers that were called in the start of the program. And if we remember in our symbol tree, right? So there's these two DLLs. So these correspond to the different IDatas and different sections of the portable execution format, right? So that's what those are. And then here's this this crackme.exe. So these are the actual data types that are being informed by the system itself. And this can see all the different types that are defined in there. And then there are these Windows ones that are down here. They're kind of in this book. And if we try to find these, we may not be able to find, so we could try to find use of them, but there aren't going to be many in here. We just, ghidra has automatically brought those in for us because we've told it to analyze it, and it knows that it's a PE file. So it's going to naturally try to bring those different things in. So one of the things that we're going to want to see is we see here in this crtdefs.h, because these are the different header files that ghidra has identified that when the code was written is being brought in, right? So there's more pieces to that we're not currently seeing here, but those are definitely in there. So I'll bring that kind of back here. So as we click through, different things are going to be found and different things like that. So here's one of those data types. So we're going to ask it to find use of, and we can see right here, it finds a lot of different instances of those of that data type that's being currently used, right? And we can kind of expand through, and we can ask it to, and as we click, it's going to change in the code so that we can keep analyzing it, right? And if we need to see a little more, we can expand our different views of the file windows here, right? So let's go back to our main. So we can get a lot more information in here. So we can click on the listing, and we can ask it to actually show specific data in different ways that we want it to, right? So like Candy was talking about, you know, addresses and mnemonics and the operands. Well, we can actually ask ghidra to try to, right, to start sorting that for us, right? So I kind of want the address field a little wider, and I don't want to see the byte field. So I'm going to go ahead and disable that because it's not really showing me a whole lot of information, but maybe we did need it to. So these are just different ways that that as we kind of start going through our code, we can find more information about what's currently going on inside of our code and get kind of a better idea of what is occurring here, right? So that's kind of that idea, and we'll just kind of keep moving on, right? So let's go ahead and let's disable our byte field, and let's go into our functions here, and let's just start pulling some more data in here, right? So as we analyze it, it'll tell us what is happening, and it's going to start decompiling it over on the other side, right? So we kind of went over that already. And then, so let's go back to our main. Because we need to find where that initial call was, right? So I got a little lost, so I just have to keep clicking through until I find it. And as I was going, and if I was actually doing this for a CTF, right, I would probably have more information, you know, on my side. You know, I would have like a notepad, and I would be writing that information down as I'm going through, right? Making notes as I'm going through, just so I can like interpret what's happening here. Okay, cool. So that's that function. So another thing that I kind of wanted to show is how we can generate a function graph, right? So that can kind of give us a better idea about what's currently happening. So let's click on our main. And let's go. So we can either select what we want from here. So it's going to display the decompiler. We can ask it to show a function tree. We can ask it to show like a memory map, so we can start seeing like where do these different pieces of the PE actually sit, and what are the different variables to them? Are they set at their volatility? What's the start Indian and the end Indian, little Indian and big Indian? Cool. So there's another thing that we can do, and we can display a function graph, right? So ghidra is now showing that, and we can go ahead and set some more functionality, right? So I'm going to ask it to start fully zoomed in so that it's a little easier for me to see. And now I'll go back. All right. So now that we have that set, let's go ahead and pull up the function map again. So I'm going to ask it to do that. Cool. And so now everywhere that we've started clicking in the program, ghidra is actually finding it for us. And as we can see, now we can actually start seeing like some of the lines of logic of how the program is executing, right? So what's the start? How does it get in? And what are the exits and entry points for some of that control flow of our code, right? And it's starting to identify, right? Like it's saying, hey, I've looked at this assembly and I'm telling you this is an if statement and this is a while statement. And as we click on some of these boxes, it'll show us some more of the control functions. And then another thing that we can do is, as we're going through this, we can actually change different registries and different things like that, which might be interesting as we're doing some static analysis. And we can also start setting comments back in the code itself to tell us like, hey, I think this might be something interesting. I think this might be something useful, and other things like that. So I'll go back to my function graph. Right. So as we go through, you know, we can see like, okay, so this is like an iterative function that's popping back up into that point. Great, cool. So that's our function map. It's very useful, and we can actually start going in and editing these code blocks, and we could even like recompile this code back. And one of the nice things that ghidra has, as opposed to some of these other disassemblers, is that you can undo things, right? So especially when you're a novice, kind of like me, and you start making mistakes, you're going to want to undo quite a bit, and that's really helpful. Cool. So let's kind of so there's a lot of tools to this. There's even like its own little Python console in here. You can write new plugins that allow you to extend the functionality of ghidra. But now let's kind of get into this idea of actually solving the crackme, right? So we noticed that what was happening is that the program was initially accepting some kind of argument from the user, right? We can see that there's an arg that's being accepted from the console, and then that's being brought in. So one of the things that we can tell with this is that this is actually probably just taking in some strings, right? So that's the main piece of it, right? Most of what you're seeing in here is actually just generated by the compiler in order to make the .exe. It's actually not that super useful for what we're trying to do. So what we need to do is we need to find all of the strings, right? So we can find defined data, and we can also find defined strings. And this is a lot of the different functionalities that ghidra has. So let's go ahead and find the defined strings. Okay. So we can see that now we've added a new tab, right? This is our main code window. And this is the decompiled C code. And these are our defined strings. So let's find where it's saying these things are, right? So if we click on the first one where it's saying, like, I guess the program name, and if we go back to our windows, right, it's saying this is the first piece that's being printed out. And so we think this is probably C code. So that's probably a printf statement. So let's go here. And let's go specifically, we're looking for password, right? So we're going to find that. So we're going to go ahead and right click on the address for password. And now we need to find any reference for that address. So we'll go down to our references, and then we'll show references to the address, right? And I kind of wanted to have it show the C code. So maybe I can get that, maybe I won't, but that's okay. And so we can also keep moving through with the arrow keys. And as we move through with the arrow keys, some more of our C code is going to change. So there's that invalid password string, and here's password. And so that corresponds to invalid password in our password string, right? So we're going to say here, okay, cool. So when we did the show reference to that password address, this box came up, and that's showing us the instructions that it's doing, right? So there's a move. So move the D word to the pointer, to the start of the stack pointer, to this local variable, and then this password is at this address. So let's get rid of that box, and let's look over at our C code. So now we finally have found where it's actually talking about in the code, right? So we're seeing that there's a char that's being set for this number, and Ghidra has this cool thing that, like, if you hover over things, it'll display out more information about it. You can also do that when you're in the function graph too. So we can see that there's an array that's being set here of 24 elements of the char. And I'll try not to move my mouse too much. And then there's an array base type and how much length it is. So it's saying, so in stack, so there's a stack that's being created. This function is taking in args from the command line. A stack is being created, and this variable is being created. So here's the start of the main. And we can also see the start of the main here in the disassembled code, right? And so here's kind of an example, right? So if we hover over this, more information pulls out, and we can see a whole lot more information about what's happening. And so we can rename these different variables if we wanted to, right? Like I could go in and I could say, like, oh, this variable here, I want to make a comment. So I'm going to set a comment, and I'm going to say password variable. Cool. And then I'm going to go ahead and hit apply. And so now when I look at this code again, there's going to be a password in here. And Ghidra also has this cool thing that the NSA developed that allows us to be like a shared program. So you can set up a Ghidra server, and people can look at your different stuff as you're working through it. So these comments would show up as in a shared project. Cool. So let's analyze the code a little more. So password, and then it's taking in this this scan here. So it's analyzing what's being brought in. In C, this is kind of like the idea, like if you've ever done C++, of like C in and C out, right? So this is our equivalent of C out, and this is our equivalent of C in, from C to C++. A lot of programs, they may actually have written this in C++, but when you actually disassemble things, A lot of assembly has like a lot of C references to it because C was originally written in assembly. So that's why a lot of this is decompiled like that. But the code was probably written in C. And we can kind of see that as we look at our symbol tree. So it's comparing this, and then it's setting ivar, which is this int, to ivar, is then equal to the string that's being, so we're doing a string comparison, and then this local C is then being set to this value. Huh, interesting. Okay, so let's go back and kind of look at our function graph, right? So if we look at this, right, so there's, so we see that there's an if statement here and an else statement here. Okay, so let's kind of look in our graph and see where that is. Okay, so here's our if or else. And so it's saying that if the password is equal to 0, right? So if the password is equal to what is an ivar, ivarl, and we do a string comparison to it, and it's equal, then we're going to print the password is okay. Else, we're going to print out that the password is not okay, and we have an invalid password. Okay, so this tells me that this might be what our password is. So now that we've disassembled our code, we can kind of go down and let's try that, right? So we're going to, we'll make a note of that, and we'll be a good CTFer, and we'll copy that into a text file. Oh, and that's another thing. So you can actually like highlight stuff in ghidra, and you could actually start just like messing with it, right? You could change everything around that you're looking at to kind of make it into an easier to read format. And you could change the different conjunctions, you can change the different functions, you could add more functions in there. And then you could actually go and like recompile the code. And then once you do that, you can then like run it again, which you might want to do, like if you want to take it from static to dynamic analysis. So static analysis is what we're doing here, where we're just looking at the code. Dynamic analysis is when we're actually running the code itself, and then we're trying to see what happens. So let's flip back to our machine where we're doing our dynamic analysis, and we'll enter our password now that we found. So that's that 2508382, and it tells us the password is okay. Awesome. So right there, we disassembled this assembly, this binary, right? That's what those .exes are. We disassembled the binary, and we eventually broke it down to where we found where the main is, right? And so here's our symbol graph for our function graph for what main is. And then we're actually finding what that reference to the password is. And then we're seeing where the local is, seeing where this variable is and where it's being added to the stack, and then what type of context it is, which is data. And so putting all of that together, right? Like whenever you start disassembling code, one of the first things that you're going to encounter is that you're like, oh, there's so much stuff in here. There's got to be something in here. All right, well, that's fine. But there's really only a few things in here that were actually useful to us, right? So what we could have done instead is we could have just asked it to search for some strings. And I'm just clicking some things here so you can kind of see what some of these different tools are. And so we could have just said, we could have just asked it to find whatever the password was. We could have just had it just search through everything just to pull it up. So let's kind of pull like a function call tree here, right? So here's another way that we could have found it. As we're going through and we're clicking on these different sections, we could have said, okay, so where does everything start and stop, right? So this main is being fed into this min-g CRT startup, and it ends at this CRTG startup. So, and there are different comments in here. So as we start disassembling things and we're looking at things, ghidra kind of really helps you dive into the code itself so that you can figure out what's going on. so that's really cool, and is really neat for CTFs. But there's some other pieces to it, right? So future wise, I'll probably try to do this here, where it's talking about reverse engineering WannaCry, and that's what this page is talking about. So you can actually start digging deep into the different code with ghidra and analyze it to the point where they are able to identify that this function in WannaCry use this different function for something interesting, and that corresponded to that URL. And if you're familiar at all with the WannaCry case, once the researcher that was analyzing WannaCry registered this domain because it was unregistered, it was able to stop WannaCry. So yeah, there's a lot of functionality to ghidra. And I'm going to keep playing around with it. I know that there's other ones out there like IDA Pro and other stuff like that, but this feels intuitive to me. This feels like there's a lot to learn and there's new features and everything like that. But what I really like is that I can kind of I can pull everything together, right? Like I could ask it to do a comparison here between the crackme 00 and the crackme 1. So that's kind of nice. Like if I had to do a series of crackmes in a row, I might be able to find more information. But I kind of like that you can do a lot with it, and as you're going through the code, you know, it'll shift it for you, so you don't have to like spend a whole lot of time, you know, like, oh, where was I in that place? And then you can kind of just dig into it and just keep doing what you need to do, and you can set comments. You can, you know, we can rename things. We could set labels here, so we could say like, you know, invalid password. Oh, and that's the wrong name for it, but you get the general idea, right? There's just a lot of ways that you can use ghidra to help you in your reverse engineering. And could you do this in a job? Sure, you might need to, but you know, this is kind of what I'm understanding that a lot of malware analysis involves is taking binaries and breaking them down to try to figure out what is this code actually doing? What is it actually saying in here? What are we really looking at when it comes to you know, this different you know, this different code itself, right? And there, you know, like I had lost my place, so I was just showing you how I could get back to it, right? I can go to my defined strings where I've set the password. I can pop that out, and then I can go back to the decompile, which gets me to the main heart of the program that we were looking for. So yeah, I mean, that's about it. I think future wise, I'll probably do a whole lot more with ghidra, because I'm learning about reverse engineering and malware in school right now, and there's endless amounts of functionality to this. And one of the main reasons why I want to do this, and I'll just kind of show that site right now, is there's this site that I've been using to kind of learn more about cybersecurity. And it has crackme challenges in here, which is try and hack me. So as I'm going through, you know, some of the stuff with ghidra, I hope it'll help me solve those different challenges and expand my skills. So with that, you know, I'm kind of done with my really quick demo of ghidra. You know, I've started reading a lot about it. So if anybody on the line has any questions, feel free to ask away, and I'll try to answer them as best I can.
So my experience, I got to recently play with it as well, and I was surprised about how good it is because my previous experience, I have more experience with Ida Pro and Binary Ninja,
Yeah.
which I both I think are really awesome. So that's why I was really hesitant about a disassembler that's written in Java, right? But it's really good and powerful. And I think the game changer for me when I was playing with it recently is the decompiler that's on the right side. That
Yeah.
is just game changing because you can see pseudocode that's in C, and that's so much easier to understand and look at than the assembly that you have in your middle window. And that's just that just blew me away, you know.
Absolutely.
So yeah, so I'm hoping to play with it more. Yeah, if you're interested in doing the one-on-one cry, I think that's really cool. And I don't know what the policy is for try hack me in terms of being able to record solutions, but if they allow it and you
Oh,
find interesting techniques, those could be like good demos too. So yeah, this is cool.
yeah. Yeah. No, and that's a really great point that you brought up, Candy, about the pseudocode over here in C, because there are a lot of languages, right, that actually are using C, to when you're compiling it to send it to the compiler, right? Like Python is that. Python is just a fancy wrapper for C and C++ code, right? So if you eventually try to create a binary in Python, right, what's going to be presented in the end, as you're disassembling it, is just mappings to some of the assembly instructions that are actually just pseudocode in C, because C was originally written in assembly. So that's why there's a lot of mapping to it. And ghidra can interact with binaries that are not just x86 binaries. It can do x64. It can do binaries for like other real-time operating systems and phones. And there's just an endless amount of things that ghidra can interact with. So yeah, thank you. Really good question.
Yeah. Uh, quickly, Craig, Mikey, any questions or comments?
No, dude, I honestly like if someone's never seen ghidra before, I thought the presentation was awesome. Uh, I thought you did a really good job.
That
Cool,
was good
cool.
stuff. Thanks
Yeah,
for
I enjoyed it.
presenting it.
Yeah, awesome. Yeah, and if anybody needs any links or anything like that, Candy, I'll happy to pass them on to you.
Yeah.
But yeah, being kind of new to this kind of stuff, because right now in school we're using like Python, using similar libraries to what you were showing, Candy, to like disassemble .exes, but that can get so tedious in the command line to like try to pull that information back. And I've tried other disassemblers before, but this is intuitive, and I just like that it's modular. I can move things around, and there's endless possibilities with it.
Yeah. Awesome. All right. So good demo. I think that sort of concludes our round of presentations for today.